Hi, my name's Al Collins. Today I want to talk a little bit about fixed tool work. Fixed tool work is using a non-motorized cutter, and you scrape your details in with a form tool. So what I thought would be a good idea was to just kind of go through the tools and techniques that I use to do fixed tool. And hopefully someone will get a good idea for it, to try it. I use a hard hinge cross slide, mostly because of the very fine cross feed and the ability to use the quick change tool post. And I grind my cutters in various shapes and various widths. But the takeaway here is I grind them, I use all the same thickness. That way, your changes in your tool post, your tool holder, are very simple. You don't have to worry about your center height, which is very important if you're going to keep your lines lined up. I grind the cutters to a 20 degrees inclusive. And that's so that the cutter can get in and out of the valleys without the heel rubbing. And now Norman Tweddle said 30 degrees, but Jeremy Soulsby's, he said he's had to go down to 15 degrees inclusive to get in and out of some projects. So I feel the 20 it's always worked for me, and I hope I never have to go to the 15. I use a Glendale to sharpen and a very simple holder, to sharpen my edges, and I use a microscope to inspect the edges because the slightest little blemish on the cutting edge transfers right into the work. So you want to look and see what you got, before you get going. These are some 1-inch wide cutters that I had EDM cut. I made drawings and sent them out, and the guy cut them for me. And these are raw right here off the EDM. And so then to sharpen them, I made these cones. This one here in particular is steel, and I sent it out and had it diamond plated, and then I made an identical one in wood that I use diamond paste on to get the mirror finish, and this actually works pretty good. I have the 1/2-inch shanks. I grab it in the lathe, and I got a center drilled on the back end, and I bring the tailstock up, and I use it in forward and reverse, and I get a nice sharpening. Small bead cutters. I have these Holtzapfel cones that I found, and thank you, Josh. And they're sharpened the same way. I use diamond to grind and diamond paste to hone. I use a retractor. This is my version of a David Lindau design, and the way the retractor works is this rod right here holds the headstock against a spring, and there's a pulley you can barely see here with a belt, and the belt goes down to some jockeys so that when it rocks you don't lose belt tension. And then the belt comes over to a pulley on the other side, and you can just barely see it here. But the pulley drives the worm, which drives the worm wheel, which drives the spur gears. And this rod unscrews or retracts at a rate of 1/1000th per revolution with these gears. Now I have another set of gears that retract at a 1/2,000th per revolution. And I use that for the wide cutters and for difficult woods. So it's very slow, but it's automatic, This is the other side. You can see the lever here, where you swing the lever and the worm comes up and engages the worm wheel, or you drop it back down to turn it off. And then this knob here is on the other side is a lock, and I can lock it in either position. And now you don't have to use a retractor for a fixed tool. You can use a screw stop like this, and every revolution you back this off a tad, and as long as your cutter doesn't stop the rotation, you're golden, you know. So you don't really need to use the retractor, but you have to sit, you have to babysit, you have to count the revolutions. This retractor, you throw the worm in gear and walk away, and it'll never cut too far because it feeds the work into the cutter and into the touch, the rosette into the touch, and the touch prevents it from going too far. When the retractor fully retracts, then all you're doing is burnishing the cut that you made. So to take that a little farther, the way you would start it is you would set the headstock vertical with the retractor, and then you would set the touch so that it almost touches the hill of the rosette, and then you feed the cutter in every revolution a little bit until the full shape of your cutter is realized, and the depth of cut that you want. And then you would introduce the retractor, and then it slowly brings the headstock or the touch into the rosette at a rate of 1/1000th at a revolution. And it starts at the hill and slowly works its way down into the valley. So let's see, let me go to here. All right, and you can see that the hill's already been cut, and I only have this little bit of the valley to finish up. And when it's done, it'll leave a nice sharp valley, and which is the signature of the fixed tool work, and probably the only way you can achieve that. Here's another example. You can see the hills of the rosette. They've already been cut, and it's just burnishing now, and it's only cutting 1/1000th of the valley. And every revolution, it gets a little smaller, and it's a gradual thing. But being that slow is very easy. It never cuts any more than 1/1000th. Imagine if you took your cutter and you just started feeding in. You're always cutting the whole detail. So this is so much easier on everything, and you can get some astounding results. You know, sharp valleys, burnished hills, you know, like that. Here's another example. I'm doing this is an OG cut. I'm doing it at an angle, and I'm rocking and pumping simultaneously. And I don't know if you can see that. You probably can't see it, but the actual video showed that it had striations, and that was a result of I didn't get my sharpening just right, and I didn't look at the microscope. I didn't, so I had to take it back, resharpen it, and do it over. But you're only taking a few thousandths, you know, once you're at this point, and it's not bad to clean that up. Here I've got a quarter round right side cutter. I'm cutting a detail. I'm trying to match this left side quarter round, and you can see I've got this little bit to do, and then there'll be mirrored images on both sides of this bead. You can do pumping only if you set up a stop. Let's see, where is it? Come on. Oh, wrong button. you set up a stop right here and your depth of cut, and then you the retractor, you push it away, and then you let it slowly come back in, and it just works very well on pumping also. Here I'm using one of the 1-inch wide cutters, and I'm using the half thousandths per revolution feed of the retractor, and I'm cutting a very bee's wing shaving off that cocabola, and anyway, so that's what that is. This is an example of lignum vita, some fixed tool work on lignum. Lignum's considered the finest wood for fixed tool because of its oily, self-lubricating qualities. So I've got some large beads and fillets and small beads. There's lily pads here, and I made a custom cutter for this detail right here for the stock. And anyway, so that's that. Let's see. In this example, I'm just showing the sharp valleys, and I line them up, and it's like I said, it's the signature of fixed tool is, how would you get these sharp valleys in there without a fixed tool? In this example, I'm showing fish scales, and I don't know if you look on the side here, you can see that the cutter had like a 10-degree angle. I used 2 rosettes simultaneously, one pumping, one rocking. The rocking is non-phased, and the pumping is half-phased every row. And so pumping rosette was half-phased only, and that's how you do your fish scales. And this is the example of a bunch of different techniques. There's coves and beads and spiraled rose engine and large radiuses, and there's lily pads, and then here's the same cutter I made, but I used a different rosette, and I used a Tudor 8 to give a different a look to it. And then up here is the same cutter, but it has I used the D8 rosette, and but it's a real small diameter, so you can see where that 20-degree angle of the cutter comes in handy. How do you get in and out of there, nice and clean without it rubbing. And so that's what I do with fixed tool and how I go about it, and I hope somebody gets something out of it, and that's me. Thank you for listening.